All right, well, I had a few minutes this morning, so for the Lithuanian speakers, see how I do. Vienas, do, tris, quatre, penke, šeši, septyni, aštuoni, devyni, dešimt. All right. Right, if you don't like those pronunciations, see me in the Ask Me Anything corner and correct my horrible pronunciation. Or ask me about the other 17 languages. Okay, so we're going to talk about continuous testing in DevOps. So as I mentioned, I'm CTO of Perforce Software. We have a lot of development tools and platforms for software developers, including Perfecto, web and mobile testing. I've been in software a long time, speak on a lot of different topics. Okay, so we're going to talk about what is continuous testing, why is it so hard, why isn't everybody doing it, right? What are the key elements? Who are the people involved? What are the challenges? How do you get around some of those challenges? Some recommendations, some metrics, and then tying it all together. How to move forward. So first, Agile Testing Manifesto. Hopefully a lot of people in the room already know this kind of stuff, and I'll ask for a show of hands. And actually, let me do that now. So who here is in software development, actually writing code? Okay, decent number. What about testers, test engineers? More? Probably two. Is the sound going in and out? Is it just my hearing? How about on the business side? Who here represents project management, product management, business testing? Okay. So a little bit of a mix, but heavy on the test side. Okay, so hopefully the people in the test and development side at least get a lot of this already, right? You focus on testing throughout, not waiting to the end. We know we get better results that way. And doing all the testing, not just the automated functional testing, but including real devices and real browsers and different versions and operating systems as you go. So you're always ready to release the code if you want to. You test what gives you the value to the business the most, not just completeness for the sake of completeness, testing every line of code, every function, but where does it matter that you spend your testing effort, right? What actually helps improve the quality, reduce business risk, and testing throughout the team, not just throwing the code over the wall to the test organization and hope for the best, but integrating everybody as one team and testing all the bits of the product that matter. So what's continuous testing? Pretty similar. It's kind of an analog to continuous integration, continuous delivery, continuous deployment. It means testing as you go, end to end, throughout, high performance, stable tests, everything from unit tests to simulating services and API tests, GUI tests on real devices, real browsers, reducing risk. There's also some things you could probably add in separate talks like managing state and things like that, but we'll focus on the core of continuous testing for this talk. So how does it fit in? Well, we think of continuous delivery as continuous integration plus continuous testing. And to get the benefits out of continuous testing, we think you need to have about a 90%, roughly 90% coverage of the product that's correct, that's stable, that gives you good results, and stable is the key. Right, well, I'll kind of hit on this a lot throughout the talk, but who here has ever dealt with flaky tests that pass sometimes, not others? If your hand is down, you're lying. Right? How many times have you run into this? Well, that test failed. Just delay 5 more seconds before you check that web page, or 30 more seconds, and then your tests get slower and slower and more useless, and nobody wants to run them. They're horrible. Right? That's kind of what happens. So it's got to be stable and fast. They either pass or fail all the time, and you don't have to worry about these time delays and things like that. All right, so this is kind of I think one of the key slides for the talk. So of the 5 stages to get to continuous testing, the first step is stable automation. That's hard enough. A lot of people never even get there, right? A lot of teams. It's all about creating and maintaining scripts or codeless, whatever it is, record and playback, visual testing or model testing, writing the scripts, making them work, ideally with the right skill sets, doing the right things. Developers are writing code, engineers are automating tests, writing code, manual testing, business testing, exploratory testing. you use the right tools for the job you're trying to get done. And you can detect things that fail and fix them, get rid of the flakiness. So it's easier said than done. I mean, how many teams never even get to this? If you get there, you can get to the next step, which a lot of teams jump ahead. They try to go straight to daily testing in cycles without making the test stable, which means you're just magnifying the problem. It means every morning somebody gets an email that says, here's all the tests that are broken, and they go, oh God, I'm gonna spend half my day just looking at these broken tests just to find out they're not actually broken. There's just some weird problem with the environment or the infrastructure, or it was just a delay needed to be added, something that is a waste of time, right? You want to get results in minutes. You don't want to have to wait 6 hours or it's kind of useless. You've already context and moved on to something else. I guess I have the cursed presentation. Hopefully this is the only one of the conference. Everybody else will do good. Me, not so good. All right. It's about getting fast results in a stable environment. It's also about having an available lab. What do we mean by lab? All the browsers, all the versions, all the operating systems you have to support, all the devices, phones, tablets, whatever your target environment is, you need to be able to simulate or emulate that and use real devices before you can feel comfortable that the software works in the real world all the time. So the lab has to be up and ready to test. Otherwise, it's useless. It's more overhead. Evidence collection, you need to get screenshots, videos to be able to see what went wrong and very quickly fix it, troubleshoot, fix the problem. Integrate with your Jenkins, your Jira, whatever, and have the ability to queue up tests, to prioritize things. So high performance tests get run above low performance ones. Maybe you have a bunch of slow running tests. You want to run them less frequently in the background. In your typical day-to-day test, you want to run fast and all the time. Dashboards, things like that. Okay, so that's, again, kind of the basics. If you get to that point, then you can have trust in the system. That's really key. Now it becomes useful and not just a burden, not just overhead. Oh, we have to maintain the test system. It's a pain. Nobody likes it. If you get to this point where it's stable, it runs fast, at least every day, then you can start working on increasing your coverage, right? Getting meaningful results every day that actually, when people look at the test and they see a failure, they want to actually fix it because they know it's real. It's a real problem to fix. Advanced validations, things like dealing with mobile devices where you need face recognition, fingerprint, the ability to insert a captured photo, right? All those kind of things you do with a modern device, you need to be able to test and automate those tests. Visual automation, record playback that's not brittle, something that's modern AI kind of based, so it's self-healing, those kind of tests. And you have to have an up-to-date lab. If you don't have the latest devices that people actually use, or you're not on the latest operating systems, well, your customers are, and they're going to find problems. So you need to be up to date. You need to be able to scale to handle all these new tests if you're running more frequently on more code, and group and analyze issues. So you're getting to the root cause and not just waiting through, 1,000 tests failed. Well, that's because the login failed because that changed, and that caused this cascade of other failures. You need to very quickly have a tool that helps you identify that, and you just fix the one problem and not get stuck chasing the symptoms. Once you're in this DevOps friendly zone, then you can work on getting to kind of the true, closer to the endpoint, like automating everything that can be automated, right? 95%. That's kind of the goal. Advanced orchestration, elasticity sharding, so you can run all your tests in parallel. So even if you have lots of tests and you run them frequently, they still happen fast. You can get results, and you're not paying for a massive environment that you're only using on occasion. You need to be able to control the environment, so you can simulate things like fast and slow wireless networks, and glitchy networks, and customers in other geographies. Right? Have all those kind of abilities to tweak, and again, test real-world settings, and deal with the scale that comes with all this. And then finally, you can move to continuous testing, where it's now not nightly, it's every time a developer commits code on every branch. They can get fast feedback with all the tests on the emulated and simulated environments, on real devices all the time, which means you're going to be executing in the cloud. You can't really do this easily unless you have a massive budget on premises. You're going to have to use cloud to handle the scale. All right, so that's kind of the overall definition, continuous testing, what it means. So some of the key aspects, kind of what we call the 4 pillars of continuous testing, ideally is with a unified solution, not a whole bunch of different tools stuck together, that handles 4 main things: creation, execution, lab, and analytics. And I'll go into detail on each of those. Test creation and maintenance, the right tool for the job, again, based on the persona. So developers need one thing, QA engineers need another thing, business testers need something else. All those advanced validations have to be part of the process. Execute at scale with all the different frameworks and open source components and things you're going to use. With this lab, again, it's kind of the backbone of testing. All those browsers and devices that you can manage, scale as you need to, with the ability to do things like install apps and handle operating system upgrades and all that stuff, and not by hand every time. And analyze results, so fast feedback, the ability to quickly see what went wrong, to diagnose it, and then fix it quickly and get to that root cause. So diving into this, I really think continuous testing is the key to DevOps. You can't really have DevOps without it. I don't know why there's a cursor up there. Right? You can have manual steps and tests that slows down your continuous delivery, continuous deployment, or it's not continuous anymore. It's not fully automated. So the testing is key, and this is where we see a lot of companies that want to get to continuous delivery, continuous deployment can't, because they didn't do the work on the testing side first. That means full automation environment with codeless, behavior-driven development, all the frameworks that you're going to need in different. I think we should all get some kind of prize for surviving the worst presentation technical challenges ever. Okay, so ability to work in all those different environments with the right tool for the right people and the right job, to be able to do object-based as well as visual-based testing, to handle all those special capabilities of the devices, the cameras and the fingerprints and all that, has to be part of it, with all the platforms and all the frameworks that you use. It has to be scalable and open, integrated with all the other stuff you use, which means all your CI tools and other orchestration tools. Flexible scaling and control, and the ability to see in your environment what are all the tests running, what are the different branches, the browsers, the operating systems, devices, reorder things, right? That's important, especially as you get bigger and bigger test bases, more developers, more geographies, kind of all sharing your resources. Secure enterprise grade lab, again, if you're spending a lot of your time fighting with physical devices and rebooting them, and that one locked and that one ran out of battery and that's overheated because we used it too much, or that Wi-Fi doesn't work, it's wasted time. So you got to have a stable lab that really works, where you can collect that feedback that developers and testers need, screenshots and videos and log files and all that stuff off those devices, so when something goes wrong, you don't have to guess. And the ability, again, to play with the environment, change the wireless, change what other applications are running on a device at the same time, networks, etc. And then get, again, in a perfect world, one user interface that gives you the results of all of this, where you can slice and dice and group by classes of failure and types of device, and to get to what you need as your daily job, so you don't waste a lot of time wading through data. And it's got to scale massive amounts of data. Okay, so key personas. We talked, kind of asked the audience. Business testers, kind of figuring out what's acceptable. What are the acceptance tests? If these pass, then I consider it safe. I'll release this code. Usual manual testing, looking around, behavior-driven development. Easy to say. Cucumber, things like that. Software engineers that are writing test code, automating things, functional and non-functional, and performance tests, and all that good stuff. And then developers, typically automating build acceptance tests, unit tests, things like that. Right? So 3 different personas with very different needs. And I think some of the challenges today, this is kind of the unoptimized model. It's a lot of different types of tools developers are testing on their local box with their local, maybe physical device or an emulator for a phone, whereas engineers in test are maybe using things in the cloud. Right, if you can see that. Different tools,
getting different reports. They're not integrated. And then the business testers, kind of down here in the corner, in the right there, what are they doing? Are they asking people? Are they able to use the software directly? Is somebody showing it to them as part of a sprint deliverable? Kind of who knows? It's sort of all over the place. Whereas if you could just pick your kind of perfect world, it'll all be in one environment where everybody gets the tools they need. Developers and test engineers can write code and use all the types of tools, JUnit, Espresso, XCUI test, whatever they want to use, Selenium, Appium, and write code and automate. Business testers can do codeless things and kind of declare what they want to happen, or using sort of these modern AI-based self-healing tests, kind of record and play back in a way that won't break every time the UI changes, as well as those interactive tests, and get the results from all these activities together kind of in one dashboard. I don't know if you can read this, but kind of a mix of codeless and various code-based tests all together in one place. So everybody can see what's happening, what's working, what's not. So some of the challenges, why isn't everybody doing this? Well, even though I think most people get that testing is what helps us go faster, not slower, still it's difficult to explain that when you're under time pressure. And one of the first things to go sometimes is there's less time to automate. Who has experienced that where it's like, well, we would love to automate this test, but we're in a hurry, just do the manual tests, make sure it looks good and get it out the door. We'll automate later. And then keep your hand up if you actually did the automation later. Yeah, no. Some people, the lucky few. But a lot of times it's like, well, then now we're stuck in permanent manual testing for that. We're never going to get back to it. Even though it helps us go faster, it's hard to psychologically pay that cost up front sometimes. Even worse, unreliable tests, all the flaky tests that work most of the time, but fail just often enough that you don't trust them, and you get nasty issues, and we'll dive down into a little bit of this. Unoptimized execution, kind of slow tests that get stacked behind each other. Like, oh, there's only so many Jenkins servers, and they're piled up, and there's a 6-hour queue of tests, right? Not very much fun. Or skill mismatch. Some people can write Selenium tests, and some people can't. Well, you want to have everybody productive as much as possible. And in maintaining the test as you get more and more of them, and then some fundamental change happens, and now they're all obsolete. That kind of sucks, right? Not easy to deal with. So some of the ways to deal with these issues, if you're not already doing it, consider acceptance test driven development or behavior driven development. Kind of focus your efforts as much as possible up front, so you're not trying to automate the test after the fact, but the automation of the test is part of the story. It's part of the deliverable. The story's not done until there's automated tests that are stable and fast. Until it's all those things, it's not done. Right? Build a consistent, unified process for CI, all the way from dev to QA to ops. Avoid, who's kind of experienced this, where the developers do their own tests, they run their own CI locally because the main one is too slow or flaky or takes too long, and they kind of have their own on the side, like, no, I'm not even looking at those results anymore. I don't trust them. I'm running my own. Right? Try to avoid that. Get everybody on the same team, and the only way that works is if everything is stable. Think about adjusting the test pyramid, where you kind of focus more on the fast running, stable, reliable tests at the bottom, and less of the kind of slow, more brittle test on top, the GUI-based stuff. And use faster frameworks if you can, headless. Don't wait on slow UIs. Now you have to do that to some extent, but try to minimize it. Lack of stability and reliability, some ways to work around that. Use tools that let you focus more on, page object models and kind of ways to identify objects and things on the screen that aren't purely visual, or use codeless or AI techniques so that your tests aren't so fragile where they break every time something changes. And maintain the test along with the code. Automated tests are code. We'll talk about that in a minute. Break up the code if you have to into modules or different areas of the application, so you can run just pieces of them so that they're fast and stable and you get that quick response. And if you have slow running tests or performance tests or something else, put that in a separate area so you can run them independently and not slow down your main tests. Use KPIs, key performance indicators, to see how you're doing throughout this process. We'll look at that in a few minutes as well. Make sure the lab is stable. Again, if you have VMs or Docker images, or you're using some web-based platform to test browsers and physical devices, make sure it's stable. It's always up. It's running. If you can't trust that environment, everything falls apart. So make sure it's always ready to go. A lot of times optimization is a problem. We talk about machine learning, deep learning, artificial intelligence for years now. It's starting to get here in bits and pieces, like with Codeless to make your test less fragile. There's things you can do to start exploring that now. Start putting tags on your tests and hooks for analytics and other things to make it easier to debug results and also see how well your tests are performing so you can look at trends. And in a few minutes, we'll see some of those examples too. Treat your test code as production code. It is real code. It should be maintained, versioned, reviewed. You can use pair programming, coaching, right? Think of it as not just an afterthought. It's just as important as the main code. So use the right object identification strategies and test frameworks. Make sure you're calculating your efficiency. How fast are these tests running? Should they be optimized? Is there something you can do to make them run better, smoother, faster? And focus on risk. So think of the main reason we test anything is to reduce the risk to the business. How will fixing this bug or preventing this bug affect the user experience, the bottom line of the company, right? Don't test everything just for the sake of completeness. Test what matters most. The areas of the app that are least stable or most likely to break, that's where you want to spend your time. And again, focus on your data, your test data as well. That's all probably a whole different talk. So some things we recommend you measure, however you do this. How fast are your tests? Speed really does matter. Right? Fast feedback means test will be used. Slow means maybe I'll get to it later. So how long do they take? Are they flaky? You have to give yourself a huge penalty if the tests are flaky. It's probably better if they're slow and stable than fast and flaky, but ideally they're fast and stable. And how much is automated versus manual? It's better to start with a very small set of automated tests that work reliably than it is to quickly have a bunch of tests that are flaky. That's a horrible place to be. Measure app quality. Are the tests mattering? Right? Are we actually stopping bugs? Are they still getting reported in production? And which areas of the app are worst? How long does it take us to find defects? Are the builds solid? Am I being efficient in my test creation? Is automated test creation in a stable, fast format part of the definition of done? Are we calling a story done and moving on before the tests are stable, reliable, and fast? If we are, we should change what done means. Include that. See why builds are breaking. Are CI runs getting slower and slower? Why? Which areas? How can we speed that up? You have to keep the whole system healthy or none of it is going to work. Right? Make sure the lab is available. Are we utilizing our resources well? Right? Is it up when we need it to be up? And then cost. It's not free to have labs and maintain it in terms of either actual payments, money-wise, or time. Is it taking a huge amount of certain people's times just to keep the infrastructure up and running? That's not good. Okay, so let's kind of tie things together. Again, creation, execution, lab, and analytics. If we kind of start from the bottom, key parts of creation are that we need the ability to do interactive manual testing. Of course, it has to be done for the business tester to be comfortable that the app is working and it's actually ready to put out and sell. You have to be able to get to your remote devices, all the different browsers on the operating systems, the phones, the tablets, whatever, and remotely control them. You don't want to have an office full of tablets and phones for every developer. Right? And you have to be able to handle all the different device orientations and fingerprinting and face recognition and image injection and recording video and audio, simulating different environments and different locations for your users on different networks with different performance and quality of their wireless connection. Right? All those things are real world environments and tests. If you don't test in those environments, your customers will. And what will they find that you didn't? So that's a requirement. You have to use, ideally, some kind of mixture of codeless, again, the smart, not fragile kind, with coding. All the different kinds of Appium and Selenium and new and old tests and frameworks in the open source that everybody knows and loves. All that's part of the creation and maintaining the test side of the house. When it comes to execution, you also need to have integration with all those orchestration and other environments you're used to. You don't have to get new testing tools every time you change a framework or find a better way to do CI. You need to be able to queue up tests, prioritize them, scale them, burst them to the cloud when you need extra capacity or elasticity. Shard your tests, again, so they can run in parallel, so you can run hundreds of parallel sets of tests, so they can run in seconds instead of hours. That's all part of execution. And then some kind of dashboard so you can visualize all that. If you've got lots of teams, different geographies, different developers, maybe they're testing on their own branches, different devices, different browsers, it's hard to visualize and understand everything that's happening at once. So you need some kind of tool that helps you see that and even see live tests that are happening where you can kind of drop in and just say, show me a live video of that test in progress. Or to be able to play back a test that failed and see it as it happened in real time is massive way to improve and speed up your tests and your results. The lab, probably you don't want to maintain a lab. If you do, you probably work for a big company that can spend a lot of money on it, because it's hard to have at least a few of every device with every operating system, different versions of operating systems, different browsers, up and running all the time for all your parallel tests from your developers and teams. So typically people use cloud. So you want a highly secure, scalable cloud that supports all the environments wherever you are. With smart healing, a lot of times, I don't know if you've run into this, but phones do weird things. They just lock. The Wi-Fi stops working. They have to be rebooted. There's a pop-up from the operating system that causes all your tests to fail. Right? All those kind of issues you want your lab to hopefully take care of for you and automatically dismiss those pop-ups and deal with that, so you don't have to rerun all your tests every time some weird thing happens. To simulate networks and environments, again, that should be part of this lab to let you throttle connections and simulate bad connections. And to collect all that data, again, logs, video, audio, screenshots, everything you need to get back, as well as things like installing applications and upgrades to see how your app works with that. That should all be part of the lab and part of that process. And you want it to be fully managed, so you don't have to do a lot of, again, upkeep yourself. It takes away your time testing to deal with the lab if somebody else doesn't do it for you. And again, your customers will use the latest, right? They'll download right from the App Store latest operating systems, or they'll get in line and get the new phone the day it comes out. Well, what if it has a notch where the camera was? Right? You need to be able to test as quickly as possible on the new devices, so you find these weird new problems. And finally, analytics. There's a lot of things that can go wrong with tests, and so you want an easy way to distinguish between what went wrong with your code, your script, with what went wrong with the backend, what went wrong with the APIs or the actual system I'm testing, versus there's something wrong with the lab. Is the emulator wrong? Did the device lock up? Versus what's wrong with my executions, right? Are they just queued up behind somebody else and they didn't run because it's busy, or there's a network issue? And so you need to be able to quickly see what is the problem so you can diagnose it and fix it. And you don't want to have to use a whole bunch of different tools and spend a lot of time to figure this stuff out. You hopefully we'll have a single UI, whatever tool you use, that puts all this together in one place. So I think keys, kind of to sum up, continuous testing, visibility, to get the best feedback, to be able to act on it and get best results. You need to have an overview of the whole CI pipeline with what's happening now as well as trends. Are we getting better or getting worse over time? That's really what the metrics are about. Are we going in the right direction? Can I focus on the areas of risk for the application that mean the most to the business? Right? Are we spending our time on what matters? And to do visual validation. It's really valuable to be able to see kind of on one screen, what does this look on this phone with this orientation, this phone, this browser, this operating system? What are the differences? Oh, that looks a little weird. Let me fix that. Easiest if you can see it all together. Noise reduction. A lot of times you'll get tests fail in big chunks, not just one at a time. What was the root cause? How can I automatically, hopefully, have my tool categorize big chunks of failures so it's reported as one thing that I can fix once, not 50 different things. And AI can help there. Test reports that get me to that root cause faster, and library of reports that let me slice and dice. Maybe I just want to look at issues related to this new device that we're working on, or this operating system, or this browser, or this part of our application. So to sum up, creation, execution, lab, and analytics all fit together to make continuous testing work. So whatever tool you decide to use, whether it's Perfecto or something else, I think those are the keys. So figure out how you need to get there to get the best results. And if you have all that, then you'll have fast, stable, automated tests for almost all of your app in all the real-world scenarios that customers come across, and you'll feel much more comfortable with your results. And with that, I will ask, are there any questions?